So let's go ahead and go over our homework from last night first. On the top part, just identify whether or not the figures were congruent, similar, or neither. For numbers 1, 2, and 4, they were similar. Number 3, they were congruent. Yeah, they gave you different measurements here for number 3, but on 3, one was a radius, one was a diameter. So if we split the diameter in half, then the radius is also 5. So those two spheres were congruent. All the other ones were similar, and we know for sure that they're similar because we checked any single one of their dimensions. We get the exact same ratio. So they have the same scale factor throughout. So if we compare 3 to 9, you get 1/3. Don't forget, look at 3 and 9. Right, that reduces to 1/3. If we did 4 and 12, 4 over 12 also reduces to 1/3. If we did 2 and 6, 2 over 6 reduces to 1/3. So every time it's the same ratio, that 1/3, that's our scale factor. Now again, you can write a ratio a couple different ways. They wrote their final ratio as with a colon, so 1 to 3, same thing as saying as a fraction, 1/3. On the next one, same thing. We compared all the different parts, you get that same ratio of 3 to 4. So they're similar. On number 4, same ratio each time. Again, it is also a 1, 2, 3 ratio. So any questions on the top 4? Moving right along. Oops, went too fast. Hold on. I scrolled too fast. All right. So on the next one, now we're looking at ratios and how they relate to the other ratios that we talked about. So on number 5, 2 similar pyramids have heights of 4 and 7. What is the ratio of the volume of the small pyramid to volume of the large pyramid? Again, whenever we talk about ratios, we have our scale factor, our area ratio, and our volume ratio. Whatever our scale factor is, our area ratio will be that squared. Our volume ratio will be that scale factor cubed. So on here, if we know the two dimensions are 4 and 7, we take the 4 and the 7 and we cube them. So 4 cubed is 64, 7 cubed is 343. You don't have to reduce anything, that's just our final answer. On number 2, it says 2 similar cylinders have surface area of 40 pi square feet and 90 pi square feet. So this time they gave us the area ratio. So they told us this one is 40 pi over 90 pi. Well, first we could reduce this. There's pi in both of those, that can cancel out. And then they both end in a 0, so they can be divided by 10. So our area ratio here is 4 to 9. Well, our area ratio is our scale factor squared, right? So how do we go backwards? Normally we take the scale factor and square it. We get here. So how do you go backwards? How do you only do a square? So squaring something is square rooting. So we take the square root of the 4 and 9. Square root of 4 is 2. Square root of 9 is 3. Now, you have to be careful on this question though, because if you read this last sentence, it asks for large to small. Currently, is that in the order of large to small? No, that's small to large. So we have to reverse it. So our final answer here is actually 3/2. If you answer your question, you should always go back, double check, make sure you answer the question that's being asked, because on this one, it's a little tricky. They reverse the order, even though they gave us the original order at the top, small, and then the big one, they reversed it in the question as to how they wanted the ratio. All right, down to number 7. Cooking. 2 stock pots are similar cylinders. This small stock pot has a height of 10 inches and a radius of 2.5 inches. The larger stock pot has a height of 16 inches. What is the volume of the larger stock pot? Round to nearest 10. Now, the correct answers are in there. It's 804.2. There are 2 different ways you can go about doing this. First option, we know both are dimensions of the small one. We only know one of the dimensions of the big one. So if we knew what we did earlier in the year, we could first figure out what that missing dimension is, right? Set up a ratio or scale factor. If I look at the radius here that they gave us, the radius they gave them both? No, sorry, height they gave both. So this one was 10, that one was 16. I can come up with a scale factor. 10 over 16 reduces to what? 5/8. Good. That's my scale factor. All right. So I got my scale factor is 5/8. Now, I'm going to have to do that no matter which method I use. So I already have that piece. Now let's go ahead and find the missing piece. So we know our scale factor. We know that in the larger stock pot, smaller stock pot, we had a radius of 2.5 inches. I'm going to set up a ratio. 5/8 is equal to 2.5 over that missing value for a radius. I'm going to call it R. How do we solve this ratio? Or how do we solve this proportion? You cross multiply. So cross multiply 5 times R. 5 times R equals 8 times 2.5. 8 times 2.5, that's going to give us an even 20. Divide by 5, and R is 4. So that's the missing radius for the bigger figure. Now, we do have an equation we can use because they want us to find the volume, right? So the volume formula, volume equals base area times height. This is a cylinder, so our base is always what shape? Circle. So if it's a circle, then our formula that goes in for base area is going to be pi r squared. Only 2 things that we actually need is a radius and height. We have both of those now. The radius was 4. The height they gave us was 16. So plug those in. Pi 4 squared times 16. 4 squared is 16. 16 times 16 is 256. That's an exact value. They said round, so multiply that out, and you get 804.2, and it was in inches cubed. Now, I said there's 2 ways to do this. Doing it this method. Did I really use anything new from yesterday? So a ratio, a scale factor, we've already talked about scale factors. We've already talked about a single dimensional. So that was one method. The other method is going to be, instead of solving for the missing radius, go straight to finding the volume of the small one. All right. Let's see. I found scale factor already. I'm going to take that scale factor, which was scale factor was 5/8. So the volume ratio would then be that same thing, but cubed. So 5 cubed, 5 times 5 is 25, times 5 again is 125. 8 cubed, 8 times 8 is 64. 64 times 8 is 512. So we have our volume ratio. We have the 2 dimensions for our small crock pot. So if I do the volume of the small one now, same formula that I used to do the big one before. So again, I'm not finding that missing radius this time. The radius of the small one was 2.5. The height of the small one was 10. 2.5 squared is 6.25. 6.25 times 10 is 62.5. Then we have to multiply that out. 62.5 times 5. Six, 1.3. So we have our volume of the small one. Now we can set a proportion. So we have our ratio. We have our volume of the small one. We need the volume of the big one. Cross multiply and solve. So multiplying those two. That gives us and divide by the 1.5, and you get the same answer of 804.24. Essentially the same steps, just different orders, right? Over there, we figured out the missing piece first by using cross multiply. Instead of proportion, cross multiply, found the missing piece. When we found the missing piece, we plugged it into our volume ratio. Over here, we first found volume of the smaller one, and then we plugged it into a proportion. Same steps, different order. When you set the proportions, you're using different ratios because over there we use the scale factor. Here we use the volume ratio. Yeah, either way works. Like I said at the beginning of the year, as we keep going through the year, there's going to be more and more ways that you can solve a problem. So 2 different approaches you could have done. All right, that was it for the front side of this. On the back side, I'm not going to do every single problem. I'm going to show you all the answers. I'll explain a little bit as I go. But it was very redundant. And again, it kept using that same idea of if you know the scale factor, then our area ratio was the scale factor squared. The volume ratio was the scale factor cubed. So, the top half, this was all dealing with the idea of scale factor versus area ratio. So they gave us these 2 figures, and they told us that the dimensions on these 2 figures were double, right? That's what they said in the directions. So on here, first thing they said is how long are the edges of the cube? Well, if they're doubling, right, that means that our scale factor, our scale factor of 2, right? Because if we're doubling, our scale factor is actually 2. 2 over 1 or just 2. Our area ratio and our volume ratio, we could also find. Area ratio would be this value squared. So 2 squared is 4. Our volume ratio is our scale factor cubed. So our volume ratio is 8. So going through this, how long are the edges of the large cube? Well, large cube, it says, is 10 inches because we All right, just doing one side, so we're multiplying by our scale factor. 5 times 2 is 10. What is the surface area of the small cube? All right, that one you have to do a little bit of work. You'd actually have to find your surface area, plug into your surface area formula, and solve. We would get 150. Once you know that surface area, though, the next part is back to using this. We already found the surface area of the small one. There's no need to do surface area at the second time. They're similar, so we're just taking that number and multiplying by 4, and we get 600. The surface area of the larger cube is how many times greater than that of the small cube? It's 4 times greater. Down here, same ideas. You have what is the surface area of the small sphere? So you would have done the surface area formula on the small sphere, and you got 36 pi. But once you had that surface area, what's the surface area of the large sphere? Well, again, just taking the surface area of the first one, multiplying it by 4 to get 144 pi. The surface area of the large sphere is how many more times greater? Again, it's 4 times as great. It appears that the dimensions of a solid are double the surface area is multiplied by 4. Again, it's just whatever that original scale factor is squared when we're talking about area. So you didn't have to do a lot of work. Now, could you have done more work and then set up more ratios on this page? Yeah. Again, if you understand this idea of when we have a scale factor, the area ratio is our scale factor squared, and the volume ratio is our scale factor cubed, then there's not going to be a lot of work on this page. Let's do this up. So, do that here because we're still doing the same thing. Because again, this is all about doubling the dimensions. So this still applies. Now we're focused on the idea of volume. So down here, the sides of the large cube are twice the size of the small cube. Again, scale factor still 2. How long are the edges of the large cube? So take the edge, which is 5, double it, so times 2, gives us 10. What is the volume of the small cube? So that one you actually have to do the volume formula for. 5 times 5 times 5, it's going to give us 125. Once you know that one, you don't have to do volume formula again. We can just take that and multiply it by 8. So 125 times 8 is 1,000. The volume of the large cube is how many times greater? It is 8 times greater. Down here on the bottom, the large sphere is twice the radius of the small sphere. So again, doubling the single dimensions. What's the volume of the small sphere? So you would have to plug that one into your formula. So again, 4/3 pi r cubed. You come out with 36 pi. Once you got that, what's the volume of the large sphere? Again, if our scale factor is 2, volume ratio is going to be 8. So that times 8 is 288 pi. So again, it's 8 times as big. So it appears that if you double the dimensions, then the volume is going to be multiplied by 8. Any questions on that page? All right, for your other assignment today. So originally last week, as I said, I was going to try and have a test by Thursday. I kind of forgot about the FSA testing in there, so kind of closed it off a little bit. I got like 11 people out today, 9 of them were testing. So they're not here today to get the review. So I will wait a day. I'll give out the review to them tomorrow if they don't pick it up today. I'd like to do the test on Friday still. I'm going to keep it this week. If by chance you're out tomorrow for testing, I will post the review, the answers and stuff online tomorrow. So tomorrow during class time, I'm going to go over the review. I'll post all the answers on the review online after class tomorrow. And then the test will be on Friday. So there's not going to be any new homework assignment tomorrow. I'm actually going to use, I don't normally do this, but for this test, I'm going to use something from this book that I've been using. So it's going to be hopefully a little bit on the easier side than some of our other tests. I am going to have it as think it's all, yeah, all multiple choice. And then next week, I'm gonna clean up some loose ends. There's a couple small topics that I either skipped over in some chapters because I didn't want to include them on tests. And then we'll start reviewing for our FSA. This was the last chapter that we had. All right, so we have, like I said, 2 or 3 little things I need to cover next week that we had skipped over. But other than that, we're done with the new material. All right. So test on Friday. Any questions? We have the rest of the class to work on this. Again, if you would, please submit them on campus. I know the network's out here, so please try submitting it when you're at home. If that doesn't work, I can open up my hotspot when I need to for my computer here in order to get you guys to submit, but please try to submit things from home before coming.